Hi Pat, this is Team ESXi-Arm, highlighting innovation from edge all the way to the cloud in the ARM booth at VMworld Barcelona. So first what I have here is a Raspberry Pi 4 with 4 gigs of RAM running full vSphere managed by vCenter and running a real VM. Next up, I have another device with 4 gigabytes of RAM in the same kind of footprint as the Raspberry Pi, set up with a little IoT sensor demo just to show folks the kind of virtualized edge use case that we've been talking about for the last few years. Next, I have the Marvell Armada-based Mercado bin. This is the community NFV development board that we used at VMworld 2018 to first demonstrate ESXi-Arm in the virtualized edge compute story. Right below that, I have an NXP Layerscape development board. We are working on enabling ESXi-Arm on NXP, and NXP is actually really excited about getting ESXi working on their chips. And we are too, because they have solutions in the whole range, all the way from $50 to $1,000. So you can right-size the hardware for the workload. Also, they have extensive, meaningful ODM partnerships and real devices at real price points for every chip that they have. Now, what's this? This is ESXi running on an ARM laptop. This ARM laptop usually runs 64-bit Windows 10 or ARM. I'm showing two things here. First, we can run ESXi on this laptop because it can run Windows. So standards are great because this thing has EFI and CPI. Second, Chinese manufacturers are talking about $250 Windows and ARM laptop with 8 gigabytes of RAM. Now, the most expensive thing about a $250 laptop is the screen and the battery. So kind of hoping there's a $100 Snapdragon-based edge compute gateway out there that could be built. Now these extremely loud things over here are smart NICs that we have demonstrated at VMworld San Francisco second day keynote. They are basically little microservers on a card. So this is the Broadcom Stingray. It's a pretty high power device. 3 gigahertz is actually faster than the Amazon ARM servers. They have the same core, it's A72 chips. It's on a special carrier board. If I were to plug in other devices into the PCI Express slots, it would be capable of using them. And of course, right over there, we see Mellanox and a smaller Broadcom device. I'm running a fault-tolerant VM on the Mellanox NICs, and we're showing vMotion on the Stingray. On this side, we have a vSAN cluster. The machines at the bottom are also Mellanox Bluefield, but they're a larger SKU. These are storage servers. In the back, there are 200 gigabit links supporting InfiniBand and Ethernet for 200 gigabits total. In the front, we have up to 16 NVMe drives. And of course, it's running ESXi and vSAN. Now, this looks like a pretty boring one new box from Lenovo. It's actually an ARM server in the Xeon D performance range. And I'm running VMs on there that are backed by this all-flash vSAN array at the bottom. Next to that, I have a vSAN at the edge demo. So we believe that edge compute is inherently an HCI play because the only way we can provide a fully fault-tolerant, resilient edge compute story is, of course, with fully fault-tolerant, resilient storage. Now, of course, we're also showing ESXi running on Amazon's A1 Metal instances. That's Amazon's ARM server chip. And what I have here is both just A1 Metal instances with ESXi and VMs, and also a vSAN cluster running in the cloud on A1 Metal instances. Everything in this booth, except for the laptop, is actually managed by the same vCenter instance, and showing a number of Linux and even FreeBSD VMs. Here you can see the Raspberry Pi 4. So there you go. Thanks a lot for your time.